So how to solve this one? Do you have any idea? So this functions, here we have to understand one thing. So Laplace transform of sin t is 1 divided by s square plus 1 square plus this h of t minus pi is there, right? So we try to get this term. We know this t minus a format only. Okay, we know that this one. So to get this in this type of format, if it is the same t minus a, here t is there. Okay, if it is not in the same form, so we may write this Laplace transform of f of t into this h of t minus a form. Okay, this can be written as Laplace transform to maintain this t minus a form, f of t minus a, f of t minus a here plus a form. Suppose we are going to use it. I hope you understand this one. Just add and subtract, right? Students, are you got the point? Or I am using the same color?
Yes, sir.
Okay, just add and subtract. Okay, this is minus a plus a into h of t minus a. So we can write. So now we will make this as one portion. It's like t minus a plus a. So we are try to consider it as f of t minus a plus a format into h of t minus a. So, I hope you got the point, right?
Yes, sir.
Okay, now how can we get this? This e minus a if I'm going to take, or this results if I'm compared this. Laplace transform of this a if I am taking out e raised to the power minus as remaining L of f of s plus a, right? Or f of s plus a is no need of this s plus a. This function of s plus a, right? Because f of t format we are having f of s, but here this plus a is there, still there. So that Laplace transform of f of t h of t minus a is we are having this results e power minus as into f of s plus a. Okay, now with this we just consider the given problem this way. Okay, this is solution is very simple. In the last class also, I think one student he suggested that. So now we are going to calculate this. So for this, Laplace transform of sin t is 1 divided by s square plus 1 square over. Then remaining here, this Laplace transform of sin 2 times of t minus pi. Am I right? Plus pi. Shall we consider in this way?
Yes, sir.
Okay, minus plus into this h of t minus pi plus Laplace transform of,
Sir,
yes.
sir, how did you put minus pi plus pi, sir?
What again we are having this sin 2t only, right? Just add and subtract. Suppose I am having this sin t, this can be written as sin of t minus a plus a. Am I right?
Yes, sir, I understood.
Yeah, the same. We need to get this t minus pi format in these functions also. That's why we are adding minus pi. Okay, here it is sin 3t t minus pi plus pi plus pi and then minus sine of t minus pi plus pi. Okay, into this h of t minus 2 pi. Suppose here we needed 2 pi means minus 2 pi plus 2 pi minus 2 pi plus 2 pi we want to multiply. So the field which a is you are having. So that's the idea. Okay, now if you are expanding this 1 divided by s square plus 1 square, Laplace transform of this is 2t minus 2 pi. Actually it is sine 2 is there, the angle is here, it is two things. Okay, what will be the answer here? Actually here if you are simplified, okay, rather doing this entire thing, okay, so I just calculating sine of 2 of t minus pi plus pi. It is nothing but if I am taking this portion sine of 2t minus 2 pi then plus sine 2 pi, right? No, this is a plus b format. Sine of a plus b. A is this is 2t minus pi plus 2 pi is b. This is my a and this is my b. Sine of a plus b means sine a. Sine a. So sine of t minus pi sine a cos b plus cos a into sine b. So this will be 0. This term will be 0 and this term is sine 2 pi is cos 2 pi is 1. So that is sine of 2t minus 2 pi. Is it clear? You got the point? Is it clear or not?
Yes, sir. Yes, sir.
Okay, then again if you are substituting this is a minus b form, it is sine 2t cos 2 pi here. Okay, sine 2t cos 2 pi minus cos 2t sine 2 pi means this term is 0. So overall it is sine 2t alone. See sine of 2t minus pi, this form is sine 2t, sine 2t. So like that this negative term of this term sine of t minus pi plus pi. If I am computing sine of t minus pi plus pi we are going to compute. So sine of t minus pi alone. Actually again it is sine t only we are going to get, right? Because it is minus pi plus pi. So the same it is this pi we are going to take anyway. So it is sine of plus pi format. So sine a cos b plus cos a sin b. So this term again vanished, it is minus 1. So minus sine of t minus pi. So with this minus of this sine t cos pi minus cos t sin pi. So this will be 0. Okay, and this will be minus 1. So minus 1 and minus 1 is positive. Okay, sin t. This is sin t. And remaining it is the next one is sine of 3 times of this one, sine of 3 times of t minus 2 pi we are going to have t minus 2 pi, then sine of 2 into t minus 2 pi. So sine of 3 minus 2 pi plus 2 pi. Okay, this angle, then the t. So what will be the answer here? This is sine 3t minus 6 pi plus 6 pi overall that. Okay, so that sine of a plus b means sine t minus 6 pi plus cos 6 pi plus cos 3t minus 6 pi into sine 6 pi. So this is 0. Okay, this is 0 and cos 6 pi is 1. So sine of 3t minus 6 pi. Again if you are expanding this sine 3t cos 6 pi minus cos 3t sine 6 pi, so that it is 0, here it is 1. So again sine 3t. See the same functions we are having, right? Similarly, sine of 2 of t minus 2 pi plus pi, right? It is sine 2t alone. So using this results, L of f of t, so it is 1 divided by s square plus 1 plus this term. Consider this term. In this term, this minus pi will be taken out here, here, so that minus pi if you are taking out, so that here it is e raised to the power minus pi s remaining Laplace transform of sine 2t minus sine t, like that. Here e raised to the power minus 2 pi s Laplace transform of sine 3t minus sine 2t is the remainder thing. So 1 divided by s square plus 1 plus e raised to the power minus pi s into, for this 2 divided by s square plus 2 square, and for this 1 divided by s square plus 1 square, then e raised to the power minus 2 pi s into the sine to 3t means here it is 3 divided by s square plus 3 square minus 2 divided by s square plus 2 square. So this will be the answers. Is it clear how we are doing that? And in simple form, if you want to understand the concept, okay, just you got the fine.
Yes.
Okay. 1 second. One second. Okay, students, I will share the parallelly two files. Okay, just go through that. Okay. Is my screen visible? Two screens I am having, right? Am I right, Pa? Can you see it?
Yes,
Yes,
sir.
sir.
Okay, so the concept of these functions, okay, this is the notes, okay, for this today's class, and the remaining things I am explained whatever I want to write, I will do it here, okay. So I am going to write here, okay. So here, but this is visible to you, right? Is it visible?
Yes, sir.
Yeah, this is h of t minus a into f of t. Suppose I am going to assume. So since my f of t is suppose my f of t is, it is until the point it is 0, okay, or the point a, suppose it is a, means by the default thing is this function is called heaviside function or unit step functions. Now this h of t minus a means is actually this is my t minus a, h of t minus a. So some functions whatever I am going to assume are multiplied. So here we multiply. So the corresponding function f of t will nature will be started. So for example, consider this graph. Okay, consider this graph. So this is my t and this is my f of t. So up to this 0 point, I'm having value it is 0. Okay, my a is here, it is 0. Okay, a is 0. Remaining after that a equals to a onwards. So it takes the value and the height will be 1. Okay, there is a jump discontinuity. This is my f of t. So let us take my f of t is, suppose my f of t is t square. Suppose we are going to take t square means this is my t and this is my h of t minus a into f of t. Suppose my a is also 1. Okay, a is 1. A is 1 means up to that 1 we are having this uh, value it is 0. Then t square will be started at 1. T square will be started at 1. Okay, so what about f of 1 equals to t square? So f of 1 is 1. So here this point onwards the nature of the function t square will be started. Okay, like that if you look at here, this is my cos t function. Cos t function, suppose in this cos t y equals to cos t, the functions h of t minus t pi into cos t, which means that here my a is pi. Just compare this, a is pi and f of t is cos t. So until this pi, my function value has it is 0, 0. Then pi onwards from the nature of the graph, of this cos t or f of t. So it is going to start it from this point. Is it clear? Students? Say yes or no? No response. Am I audible?
Yes, sir.
Sir, can you repeat it once more?
Yeah, okay. So the graph is suppose this is my cos t functions I am having. Okay, so the cos t function, suppose we are having that in this manner. So this is my t and y equals to cos t. Suppose this unit step functions at pi, this is my pi. Okay, into this cos t I am going to compute. Okay, this is cos t. So this t, this h of t minus pi into cos t graph will be up to that this pi point, it makes it is 0. The left side of this point pi up to that pi, even though here it is having the graph by this unit step function or the heaviside function, it is 0, right?
Yes, sir.
Then pi onwards, it is going to start from the nature of the graph itself. So here itself, it is going to start in this way. It is not going to start about this point, but this point onwards. So what pi? What is the actual function? The graph will be started. That's here we are having. Is it clear?
Yes.
Okay. Now the functions here, the pulse. In the last class itself, we discussed pulse means suppose I am going to have this value. Suppose consider this graph. Actually, what is this graph? So until this A point, okay, my height is suppose this is 1, and this is my B. Okay, so here if I am going to write this function, this is my function means this f of t. If I am going to write this A, actually it is till that it is 0. Then after this B also it is 0. Okay, t less than A, it is 0. Then t lies between this A and B if we are having that. Okay, and particularly if we are going to have it is a disk like this means, so here it is included but this is excluded. Okay, so this function is having the value at 1, then t more than of that b it is 0. Am I right? This is my function, right?
Yes, sir.
So this functions, using this pulse functions, okay, the actual function of this f of t from the graph or from the function itself, graph to functions we can write either are functions to this graph we can plot, okay, any one of the form if it is given. Then what about this functions f of t we are going to write in terms of the heaviside functions. Why we are discussing this? In solving ordinary differential equations, the right hand side function, the f of t, the homogeneous part, right? This is y double dash minus 2 y dash plus 3 y equals to this f of t, where f of t is this one. Then this directly we cannot take Laplace transform between this interval. Okay, so we need to write this f of t in terms of this using this heaviside function. Is it clear?
Clear, sir.
Okay, so how to write this? How to write this? We know that we know the impulse function definitions here. Impulse functions definitions here. To using this impulse function, this is about 0 times h of t minus a plus this functions, pulse functions, the constant times constant time. Okay, here my constant is here, it is function 1 into this h of t minus a minus h of t minus b plus 0 times h of t minus b. T minus b. In this way we can write this function. So for this now we are going to take the Laplace transform. That's the idea. So for example, suppose this is my f of t. Forget about this these things. Okay, 1 minute. The graph, you just assume this one. This is for about the point 1. All the information here in the text manner also it is given. You can go through that. So now my functions f of t is defined in this way. My function, if t less than 1 is 0 and 1 less than or equals to t less than 2 is, it is e raised to the power t, and t more than of 2 is also 0, then can you have the graph of these functions? Until 1 it is 0, right? Then from 1 onwards it is going to have, right, like this, right? This e to the power, e raised to the power t. Actually e raised to the power t we are having in this nature, right? So we are actually we are going to pull down this function up to this one point. We make this line as 0 0. The 0, the value becomes, it is 0. Then up to this it is 2 2. Remaining, it is remaining more than of the 2. The functions here onwards, whatever we are having the graph, it is going to have this one. That's it. That is, it is here, it is given from this one. Okay, the corresponding function of this heaviside functions, h of t minus 1 into minus h of t minus 2 overall into this e raised to the power t. Actually f of t, but this interval only we are having that it is e raised to the power t. So the corresponding f of t can be written as using this interval into this function, it is called pulse of a function. Is it clear? Students, so give me by immediate reply whether you understand or not, whatever it is. Okay.
Yes, sir. Understood.
Yeah, this is y equals to t square. Suppose I want to plot the functions y equals to t minus whole square, actually h of t minus 2. The points are same at 2. Okay, then what will be the nature of the graph? This is t and this is y. Okay, then this is my t and this is my y of t actually. So at 2, at 2. Okay, so here you have to understand one basic concept. Suppose we are having this concept, this y of t is t square h of t minus 2 means until this 2, like our previous example, until this 2 we are, suppose this is my 2, so we are going to make this r, this curve natures to be 0. After that 2 onwards, so what about at y at 2? So it is 2 square, it is 4. So the height 4, the 2 comma 4, it is going to have this nature. This is t square minus, sorry, t square into h of t minus 2. But the same case, t minus 2 whole square, this 2 involved here also, the 2 involved here also, so that my functions will start here up to this, it is 0. Then here this point 2 itself, the nature of the graph will be having this t square graph. Okay, actually we are reducing the magnitude of this height. Okay, magnitude of this height. Okay, the jump test discontinuity we reduced in this format, but here we are having the discontinuity. Is it clear?
Yes.
Yeah. Okay, now the problem wise we are going to write. Okay, and taking the Laplace transform of that in this problem. So find Laplace transform of g of t. Okay, find Laplace transform of g of t. This is my problem part. So, and before that, Laplace transform of h of t minus a into f of t minus a means this is e raised to the power as into remaining Laplace transform of f of t. Okay, so that e raised to the power minus as into f of s. So this a should take outside of from both the things. Then this h will be vanished because h of t. Okay, here it is going to vanish. So remaining L of f of t only there. So with this L of f of s. So L inverse of e raised to the power as f of s means this can be written as the corresponding f of t. T will be replaced by t minus a into h of t minus a. So this can be written as f of t minus a into h of t minus a. Is it clear? Students? Have you see you understand or not? So I'm waiting for your reply. You are not simply sitting. You are not answer and that's
We
it.
understand. We understand.
Huh? How many times I told? We are in the rush week, right?
Yes, sir.
Please reply me immediately. So these functions, consider these functions. Okay. So this is my 0 less than or equal to t less than 2. It is 0. Then t greater than or equals to 2. It is t square. This is my function. Okay. So find the Laplace transform of this function g of t. Either graphical, since they may be given or not given. So what is the graph? It is 0 to from it is started from 0 until this 2, it is 0. Until then it is 0, then t greater than or equals to 2. At t equals to 2, it is t square. If we are included, it is 4 square, right? 2 square means it is 4. So 4 onwards the graph will be started. This is the graph of this my functions. Okay. Anyway, until this 2 is, it is 2. So it is obeying the nature of my Heaviside function. Heaviside functions. Okay, so here we are having that. Here we are having that. It is we are having this nature. So Laplace transform of t. So using the pulse functions, now we are going to write using the pulse functions nature. So how can we write this g of t? This g of t. So anyway here if you want to write this using the pulse function. It is 0 times h of t minus 0 minus h of t minus 2. Am I right?
Yes, sir.
Okay, the pulse 0 into. So it is t square into h of t minus 2, right?
Yes, sir.
So here it is t square plus 1. Okay, plus 1. Okay, consider this is plus 1. Okay, I missed it here because it is given here. Okay, t square plus 1. Okay, so this is the nature of this one. Okay, so this is my g of t. And we transformed this g of t using from this piecewise functions to this pulse functions. In one line form, we are writing the functions. You got the point why we are using the pulse function?
Yes, sir.
Okay, man. Now, if I want to find this Laplace transform of g of t, so Laplace transform of t square plus 1 into h of t minus 2, so that if I want to take this as, I cannot simply take this t or the at 2, okay, at t equals to 2, we cannot take e power minus s form. So we are doing some add and subtract manner. Wherever the t is there, at this point, this 2 is, we need this structure so that t minus 2 plus 2 form we are going to have plus 1 into this entire, this is t minus 2, so that this is I'm going to make this form as a plus b. So a plus b whole square, it is what? A square plus this b square, already 4, here it is 5, so t square plus 5 plus 2 times of ab, right? Already 1 2 is
Yes,
there,
sir.
so 2 into 2 it is 4, so 4 into t minus 2,
2 minus 2.
2 into this h of t minus 2. Now from first these two term, we may take it as this 2 is outside, so that e raised to the power minus 2s remaining Laplace transform of t square plus 4 times of, now at this point 2 and this 2 for here, because it is in the form of multiplications. Okay, so 4 times of e raised to the power minus 2s into Laplace transform of t plus 5 times of Laplace transform of h of t minus 2. So for this h of t minus 2, we may take this as e raised to the power minus 2s remaining Laplace transform of t. Only one is there. Okay, only one is there. Actually, it is Laplace transform of 1 is there. Okay, Laplace transform of 1 remaining, it is Laplace transform of 1 is there, so that here if you are applying this is e raised to the power minus 2s. T square means 1 divided by s cube. Okay, and this is 4 times of e raised to the power minus 2s means 1 divided by s square plus 5 times of e raised to the power minus 2s divided by s. Okay, this is the corresponding Laplace transforms. Is it clear? And here I
And
this Laplace transform of t square means it is 2 factorial divided by s to the power 2 plus 1. So here this 2 factorial means it is 2. Okay. So this add and subtractions we should know.
Sir,
Okay.
how
So
did
all
you
the
get
details
L
here.
of 1, sir?
This
In the
Laplace
last
transform of,
term?
okay, Laplace transform of h of t minus 1 you are having, right? Or t minus 2 you are having. Which means that here my
Yes,
function
sir.
is 1. F of t is 1.
Yes, sir.
Okay.
Oh,
It's
okay, sir. I
constant.
got it.
You got it? Or
Yes,
you,
sir.
if you are confused, this 5 itself you made it here. Laplace transform of 5. The answers will be same. 5 times
Yes,
of
sir.
this
Got it.
divided by s, right?
Yes, sir.
Yes, pa. So all this information here it is listed out with the explanations also. I'm just trying to explain here. Okay, because this material it is not mapped with this notebook. Okay, so that's why parallelly I'm writing. Okay, and I hope you got the things. Okay, in the video you may just check it parallelly. Okay, whether if I am deleting it, this video you may use it. Okay, all the informations here I am added properly. Once again, if it is going to be right. Yes, now consider this compute L inverse of this s into e raised to the power 2s divided by s square plus 4. Okay, so this exponential whenever it is involved in your function, it is L inverse of f of s. So that time we should use this heaviside function or impulse functions. Okay, so here this functions is involved. So except this e power minus 2s, what is we here we are having that L inverse of this s divided by s square plus 4. So with this we know that it is cos 2t. Now L inverse of s into e raised to the power minus 2s divided by s square plus 4 means this is my f of t. See, we are going to use e raised to the power minus as into f of s means that f of t we are going to compute the corresponding f of t we are going to compute that f of t will be replaced by t minus a along with this h of t minus a also. Have you got the point?
Yes, sir. Got the point.
So this cos 2t will be replaced by t tends to t minus 2. So cos of 2 times of t minus 2 multiplied with because of this exponential we should write this h of t minus 2 also, whether it is 2 or 3. Yeah, here I consider it is 2, so that's why here I write it here, but the problem they are used it is 3. Okay, if it is 3 means problem here this a is 3 means here suppose we may use to here it is 3, then here it is 3 times s means here this t will be replaced by t minus 3, then it is t minus 3 here also t minus 3. Is it clear?
Yes.
Okay, pa. Now okay, so now the problem I will solve properly. So for these are all for the understanding purpose, that's why I skipped this. Okay, so now solve the ODE. Solve the ODE initial value problem. Okay, y double dash plus 4 times of y, which is equals to f of t with my initial conditions y at 0 and y derivative at 0, both are 0, where my f of t is, it is defined as until this t it is 0 and t greater than or equals to 3 is it is 1. So the solution first given equations y double dash plus 4y is this is 0, t less than 3, 1, t greater than or equals to 3. Okay, by Laplace transform we have to solve. Okay, so directly the right hand side functions we cannot solve by Laplace transform. Am I right? Am I right? So this given f of t will be written the form of pulse function, right?
Yes, sir.
Okay, pulse function form. But this also same f of t only, right? Same f of t only we are going to write. So what about your f of t? So this f of t 0, t less than 3, 1 greater than or equals to 3 can be written as 0 into h of t minus 3 plus 1 into h of t minus 3. Am I right? Or sorry, it is t. So sorry, here it is t. So So here it is not 1, it is t. So I'm going to use t. Sorry. So here it is function is t. Okay, t. Okay, t here we are going to have. So shall we write in this way? This
Yes,
is my
sir.
f of t. So the given problem is y double dash plus 4y equals to t into h of t minus 3. Am I right?
Yes, sir.
Okay, so if you are applying Laplace transform on both sides, we need to get here t minus 3 plus t plus 3 format, right? So for that reasons, I am just trying to write in this manner, so that my solution of this problem is very simple. Is it clear?
Yes, sir.
Okay, Laplace transform of this h of t minus 3, this minus 1. Okay, apply the Laplace transform on both sides. Laplace transform on both sides. Y double dash plus 4y equals to Laplace transform of this h of t minus 3 into this t minus 3 plus 3, suppose we are having, so that this is s square y of s minus s into y of 0 minus y derivative of 0 plus 4 times r plus 4 times r plus 4 times r y of s y of s. This is equals to, from first time I am going to consider, this is L of h of t minus 3 into t minus 3, okay, plus this 3 times of or Laplace transform of h of this t minus 3 into 3. Am I right? Shall we write in this way? Students?
Yes,
So
yes,
this
sir.
term and this term separately we are writing, that's all. Since
Yes,
y
sir.
of 0, y0 and y at 0 are 0 at t equals to 0, right? At t equals to 0, both are 0. So here, this term will vanish, this term also will vanish. So remaining it is y of s, if I'm going to take out, okay, remaining it is s square plus 4 equals to, from these two, if we are applying Laplace transform, e raised to the power minus 3s, remaining Laplace transform of t is there. T means 1 divided by s square plus, here e raised to the power minus 3s, remaining it is Laplace transform of 3 is there. So that 3 divided by s. Okay, is it clear?
Now, how did you evaluate the left side, sir? Like s square into y of
No,
s.
these two
How did
terms
you
we are
do?
taking the common thing, right? From these two terms, you are going to take this common term, right?
No, sir. The before step, sir. Like,
Right?
how did you find its Laplace, sir?
How did you find Laplace? Sorry, I didn't get.
Sir, how did you find the Laplace of y double dash?
Oh, sorry, I think in the solving the ODE we discussed already, right? This formula we know that, right? Can you remember or not?
Didn't tell, sir.
We discussed, right? Solving ODE, whether we discussed or
No,
not,
I
No, sir.
don't think so, sir.
No, sir. We didn't.
whether we are having the D1 slot, right? This inverse Laplace transform. I think this is E1. Once again, more. Oh, we are not discussed data. Huh? Okay, ma'am. That's why. Yeah, okay, ma'am. Your question is correct. Okay, then I will do one thing. Okay, using these results. Okay, in the one more problem I will solve. That time you can understand. Okay, so using the derivatives formula, whether we discussed. This Laplace transform, this material we are having, right? This division by t and all we
Then
discussed.
the inverse of derivatives we discussed, sir.
No, say loudly, ma. I can't get your voice, pa. Increase your volume.
Then the inverse of derivatives we discussed, sir.
See, this, no, not the derivative. This case already we discussed. Just kindly check your notes. Under the Laplace transform. Laplace transform of first derivative means s into f of s minus f of 0. Second derivative means s square f of s minus s into f of 0 minus f derivative 0. Triple derivative means these things. Okay?
Yes, sir.
Okay,
Yes,
this
yes.
Yes, sir,
yeah,
it also.
yeah, already we know these results. Here we are going to assume that f of t means it is f of s.
Sir, our next class started.
Started.
Next started.
One second. Okay, you may go now. Next class we will discuss.
Thank you, sir.
Okay, ma.
Thank you, sir.
Thank you, ma.
Thank you, sir.
Thank you, sir.